All right, hello everybody. Let's go ahead and prove this theorem on GCDs. It says that for all A, B, and Z, with the D equal to the GCD of A and B, the GCD of A over D and B over D is 1, always. Okay? So really then the way of looking at this is nice, is that once you pull out of A and B, the things that are in common to both of them, they have nothing in common anymore. That's all this says. Okay? So let's go ahead and prove it. So first off, law of universal generalization. I better create the A and the B. So let A and B be any two integers, and let D be their GCD. Okay. Now I need to show that GCD of A over D and B over D is 1. So I'm going to say let C be that GCD of A over D and B over D. Okay. So my goal is to now show that C is equal to 1. So how are we going to go about that? Well, then, by the definition, what does it mean to be the GCD of two numbers? It means that C divides those two things. So I know that C divides A over D, and C divides B over D. Hey guys, if you are looking for help with learning discrete math or proofs, I know they're tough, then make sure to subscribe, as I'm literally going to be posting every example I have here for free on YouTube to help you learn and understand discrete math proofs. Back to the example. Well, what do those mean? Follow the definition of divides. If C divides A over D, that means there exists a K in Z such that CK is equal to A over D. And if I've got CK equals A over D, well, then I can multiply by D on both sides. And what I get is CKD is equal to A. In the same way, if C divides B over D, well, then there exists an L, say, in Z, such that CL is equal to B over D. And again, multiplying by D, I get then CLD is equal to B. Now, it looks like just a lot of letters right now, but watch what happens here now when I look at this situation. I've got C and D are together form a factor of A. So let me just emphasize it. Then CD times K equals A. CD also times L equals B. See that here? And so what I've got is that CD is a common factor of A and B. And so CD then must be certainly less than or equal to the greatest common factor of A and B, because it is a common factor. Whatever the greatest common factor of is CD, that thing must be less than or equal to it. And of course, what is the GCD of A and B? That's D. And so what I have is CD is less than or equal to D. D must be a GCD, which is at least 1. And so I can divide by it on both sides, and I get C must be less than or equal to 1. Now, I know that C is the GCD of two numbers. That's always at least 1, because 1 is always the divisor of two numbers, and therefore, at the very least, 1 will always work as a GCD. Well, I've now shown that C is also less than or equal to 1. Thus, C, which was the GCD I was looking for, A over D and B over D, does in fact equal 1, and we're done. Okay, so leave that there. Have a good one. We'll talk to you again. Hey, thanks for watching. Remember, what I've explained here is just a tiny, tiny example in the literally infinite space of problems there could be that you'd run into. So, if you're interested in really understanding this content, getting a good grade because you understand the content, go ahead and click the first link down below and book a free call with me, and let's talk about if I can actually help you do well in this course.